Hey, this is a small video in which I'll be talking about how to model a three linear equation solver in Simulink by using Simulink ready-made blocks. And sorry for posting the video so late, but I'll try to be as regular as possible. So let's get started with the video. On the screen, you have an example of three equations, and with the help of this example, uh, we will see how to model a linear three equation solver in Simulink. So let's get started. So this is our Simulink model. So we have some basic blocks here. So let me introduce you with the blocks that we'll be using. The very first one is the solve block, and then second one is the elder block. Then we have the gain blocks, a constant block, and display block. So the solve block is basically will help us to solve the equation, and the block works on the following principle: f of z is equal to 0, where f of z is a function and it's equating to 0. That is what a normal solve function does using Matlab, which I had explained in the previous Matlab codes. Then we have the display block for displaying the value of x, y, and z that we will be getting in the form of output. Then we have the adder block. Adder block will basically add the signals of x, y, and z and make it in the equation form. Then we have the gain block. The gain block is basically used to define the coefficients of the equation. So as our equation is in the form of ax plus by plus cz is equal plus d is equal to 0, so we have three gain blocks for x, y, and z and a constant block for representing d in the end. By adding all the signals, we can form a single equation of ax plus by plus cz plus d is equal to 0. And similarly, we have three equations, so we have kept a set of three of each blocks. So let us see the very first step. The very first step is to generate the first signal, that is the signals of the variables. So we have three variables here, x, y, and z. So we want three signals. So let us assume that the first solve function gives us the x value, the second one the y, and third one the z. So let us connect the solve block to the display block. So as we have assumed the first one is x, so whenever in whichever equation we require an x variable, what we can do is drag another signal originating from the first signal and connect it to whichever block that requires an x signal. Similarly, we can do for y and z. Now let us make the first equation. So the first equation is 6x, so we need an x signal. So what we do here is first drag an x signal and then connect it to the gain block. So the gain block will just multiply the x signal into the amount of gain. So here we have 6, that is what we get from here is 6x. Similarly, let us do for y. We want minus 5, so the gain value is minus 5, and we dragged an signal from gain block and connected to an adder. So we are adding it 6x minus 5y, and similarly we do it for z. Then finally we connect a constant block to the adder and make a final equation, that is, and then we connect the all added signals to the solve block. So that is how we made our first equation. Now let us make all the equations. The second one, we need x in front of 3, so that's 3x. Then we have 4y, and then we have 2z with a constant of minus 7. So let us connect all the gain blocks as well as constant block to the adder, and then we connect it to the solve function. Similarly, we build the third equation, that is 7x plus 3y plus 5z plus 5 is equal to 0. Now you just have to check that all the blocks are connected. There is not any unconnected block that will generate an error. So that's the final step, and then you have to just run the code to get the results. So that was it from this video. So as you can see, we have got the display, got the values of x, y, and z in on the display. So finally, we have our block. We have our model of three linear equation solver. And thanks for watching.